Hello everyone, Tunia. Class 12 Chemistry is in Unit 12 here. Topic here aldehyde, ketones, and carboxylic acids here. Masana objective is in view. That's a minor humor. Number 1, nomenclature. It's a naming of aldehydes, ketones, and carboxylic acid. Number 2, nature of carbonyl group. 3, methods of preparation. 4, physical and chemical properties. 5, mechanism of nucleophilic addition. 6, reactivity of alpha hydrogens in aldehydes. 7, uses of aldehydes, ketones, and carboxylic acids. Today, simply move aldehyde, ketones, and carboxylic acids. Aldehyde is a functional group RCHO. Here, ketones RCOR prime. R is a alkyl group where R and R prime so carboxylic acid RCOOH. COOH is a carboxylic acid group. So R is an alkyl group. So simplest alkyl group CH3. Here CH3 then is substituent. You have CH3 CHO. CH3 CHO then common name here acetaldehyde. So this acetaldehyde mean here acetic acid dapat derive here. Acetic acid then here nature of carboxylic acid then mean here nature of dapat derive is here ki all the names are derived from the compounds. So, the carboxylic acid here are simplest R CH3 methyl COOH here. So the name is acetic acid. Acetic acid CH3 COOH with acetic acid. I can say here CH3 CHO with acetaldehyde. Second one, ketones. Ketone, simplest ketone. In the R group, you have R prime. Here R to R prime ke bang CH3 methyl, CH3 another methyl. So ONE ketone pen, ONE again. So this is called acetone. Again 1, 2, 3, 3 carbon here propanone. Nomenclature of aldehydes means common name name to corresponding carboxylic acid and replacing the suffix -ic with aldehyde. Then again carboxylic acid dapat amina derive aldehyde. So OIC acid is replaced with aldehyde. Masana in the H CHO H pen in the R RCHO aldehyde group. So HCHO is the simplest aldehyde. Common name is the formaldehyde. So IUPAC name carbon atom cut on one carbon atom is meth. Okay. METH meth. So IUPAC name is alkan plus Al. So meth plus Al methanol. Same thing. CH3 CHO 2 carbon atom. So 2 carbon atom is eth plus Al ethanol. Okay. 1 2 3 4 1 2 3 4. Next example number 4 carbon atom then butanol. So this one 1 2 3 carbon atom number 1 2 3 so CHO pen aldehyde suffix here Al. So 1 2 3 3 carbon pen propped then double bond pen En. So 2 position of double bond hyphen 2 hyphen E then hyphen CHO pen Al. So prop 2 in al. Nomenclature of ketones apa ini? Ketones common name ini alkyl plus ketone ini IUPAC system ini alkene plus on on. So yeah, and then okay. RCO apa sebenarnya COCH3 no methyl group ni on na dimethyl plus ketone no common so dimethyl ketone na IUPAC ni na how many carbons 1 2 3 carbons and I made a propane plus on propanol. Now this side is methyl, the other side akan pilih CH3 CH2 pilih ethyl no balik ya naming of compounds higel na alphabetical order higel na this is methyl pen M akipan no this is ethyl pen E akipan ya E akipan na E higel na sign so you have ethyl methyl ketone okay then IUPAC name name dibang kita ni how many carbons 1 2 3 4 no 1 2 3 4 carbons 4 carbon is butane so butane plus ONE butanol so kita dua ketone to aldehyde kini the principal functional group if both aldehydes and ketonic groups are present in the compound then aldehyde group is considered as principal functional group and ketone group is regarded as substituent. It is named oxo along with a number to indicate its position. So in a carbon chain or compound so aldehyde functional group ketone functional group no so compound kata aldehyde to ketone group pang ani other contain no so other option no aldehyde ahili principal functional group principal functional group ahi mana numbering pen aldehyde ke pen ki ge demo so example ending this is CO pen ahili ketone CHO pen ahili aldehyde so numbering starts from aldehyde 1 2 3 4 5 so a ketone pen group khat no aldehyde pen functional group sorry aldehyde pen principal group ahi manena ya ketone pen substituent ni ta no substituent ahi manena oxo which is no so 3 position of ketone group so you write 3 oxo carbon number 5 is pentane plus Al is aldehyde group so I'm going to hit a 3 oxo pentanol same thing here ketone group this is methyl group another one here aldehyde group no so aldehyde group to ketone to methyl group form now atoma form pen principal function pahile aldehyde demo aldehyde ahi mana starting number yang hele ya aldehyde ahi pan demo 1 2 3 4 5 6 okay so 4 oxo 2 methyl so we write 2 methyl hyphen 4 oxo hyphen 6 carbon atom no 6 carbon atom here hexane hexa plus Al hexanol I mean here 2 methyl 4 oxo hexanol structure of carbonyl group the carbonyl carbon and aldehydes and ketones are sp2 hybridized and hence form 3 sigma bonds the fourth valential electron of carbon remains in its p orbital and forms a pi bond with oxygen by the overlap of p orbitals of oxygen. Thus, the carbon and the three atoms lie in the same plane with an angle of 120 degrees between them. The CO1 is polarized due to higher electronegativity of oxygen relative to carbon. The polar carbonyl group is regarded as a resonance hybrid of the two structures 1 and 2. So carbonyl carbon aldehyde to ketone na amma. Ini carbonyl carbon pen ini sp2 hybridized here. sp2 ma. In the sp2 hybridized carbon in a three hybridized orbitals of sp2 forms 3 sigma bonds. Yeah. 1, 2, 3. No. Double bond on China khat ahile sigma bond here khat ahile pi bond. No. Okay. So carbon in a sp2 hybridization and imanina it becomes planar. A structure can planar on him with an angle of 120 degree. Okay. Then the CO bond pain, C and O pain, O is higher electronegativity, meaning oxygen is highly electronegative compared to carbon. No, a difference in electronegativity of marina, they become polarized. No, so since they become polarized, oxygen in a minus charge, carbon in a plus charge. No, so carbonyl group in a structure 1 or structure 2, normal to the charge on low charge on now. Carbonyl group structure pen another one on the. So preparation of aldehydes and ketones. Number 1, by oxidation of alcohols. Oxidation, which is addition of oxygen. No, aldehydes are prepared by oxidation of primary alcohols with potassium dichromate in presence of sulfuric acid. So primary alcohols when you oxidize cyanide, you get aldehydes. Okay. So CH3OH, the oxygen you formaldehyde. CH3, CH2 happens CH2. CH3, CH2OH plus addition of oxygen, you get CH3, CHO. Ethanol, acetaldehyde. While ketones are prepared by the oxidation of secondary alcohols with sodium or potassium dichromate of concentrated sulfuric acid. Ketones are secondary alcohol are prepared. No. Secondary why? Because this carbon pen carbon catechism no. Carbon needs secondary alcohol no. So secondary alcohol pen oxidation reaction you get ketone. So 1, 2, 3 dimethyl ketone or acetone. No. Second one, Grignard's reagent. Aldehydes can be prepared by the action of Grignard's reagent with excess of ethyl formate. So, Grignard's reagent CH3 CH MgBr. So, Grignard's reagent CH3 R MgX. General formula. So, R MgX. Okay. So R pen is methyl group, Mg magnesium ke bang X is a halide. You have Cl, chlorine, bromine, iodine. Okay. So Grignard reagent pen ethyl formate to reaction you get acetaldehyde pen aldehyde. Ketones can also be prepared by the action of Grignard's reagent by using acid chloride. So ketone hi le Grignard reagent zangina ki bol thei to amo aldehyde ki bol dawina. So ketone, sorry, acid chloride, so COCl te group te hi acid chloride je amo acid chloride to Grignard reagent ki bol kam zangina you get ketones. So distinction between aldehydes and ketones. This can cut on ma te akigal suka na test te na aldehyde compound te hi aldehyde hiam ai le ketone hiam chi khen te na dimo te khen na depend na reaction ma hum ke ho. Number 1, filling solution aldehyde in a red precipitate form ketones in a form. Second one, Tollen's reagent silver aldehyde in a silver mirror form himali ketone formula. So Tollen's reagent is an aldehyde ketone differentiate number 3, shift reagent in aldehyde pink color precipitate form himali ketone formula. So same thing, reduction with lithium aluminum hydride in aldehyde reduces to alcohol, whereas ketone reduces to secondary alcohol. So number 6, action with alcohol. Aldehyde alcohol to be reaction acetal form ketone se hele form dogma. So reaction can cut aldehyde to ketone can be. Physical properties of aldehydes and ketones. Aldehydes and ketones up to C11 members are colorless liquid except formaldehyde, which is a gas. Some aldehydes 8 to 15 carbon atoms possess fruity odor and are used in perfumery. Soluble in or polar organic solvents. Boiling points are comparable to alkanes of similar molecular mass but lower than alcohols. Like in aldehydes and ketones, carbon 11 member tanpin, colorless is a color on liquid here formaldehyde starting aldehyde pen HCHO pen gas. So some aldehydes can cut in again pen game to cement game my pen amount aldehyde can cut perfume or other. So aldehyde polar organic solvents are dissolved thing so boiling point of aldehydes alkane date lower than alcohols is boiling point chemical properties of aldehydes and ketones. Number 1, nucleophilic addition, oxidation, reduction. 3, halogenation, reaction with alkalis and special reactions. So nucleophilic addition reaction and nucleophilic addition in carbonyl group, the electron density of the pi electron cloud is more towards oxygen atom. Due to this, the oxygen atom carries a small negative charge, while the carbon atom is slightly positive charge. This makes the carbonyl group highly susceptible to nucleophilic addition. So carbon to oxygen pair electronegativity because of difference in electronegativity the oxygen pair negative charge becomes negative, carbon pair becomes positive. So carbon positive this favors and nucleophile incoming nucleophile group can cut charge extra electron negative charge can cut nucleophile can cut carbon positive easily attack easily keep bond form thing. So since carbon is positive, nucleophile this is negative, positive attract so negative attracts the positive or positive attracts negative, whichever. So you get NU. So NU nucleophile in a carbon bond form. Okay, after that O minus H solution H line in hydrogen line in it becomes OH. Okay. So why are aldehydes more reactive than ketones? Number one, aldehydes are generally more reactive than ketones in nucleophilic addition reactions due to steric and electronic reasons. Sterically, the presence of two relatively large substituents in ketones hinders the approach of nucleophilic carbonyl carbon than in aldehydes having only one such substituent. Okay, aldehyde they are C double bond O. Okay, H mo. Ketone ini R O mo. So again ini the aldehyde na alkyl group khatsok ni mo. Mana ketone na alkyl group 1 2 ni. So ketone na group ni ani manina a group te alkyl group te lian zong mo. Anda de changina steric is changina incoming nucleophile adinga space on no mo steric hindrance a group te a compound te atom te clash thai mo, that is called steric. Okay, so aldehyde is more reactive because it has only one R group compared to ketone. Okay. Electronically, aldehydes are more reactive than ketones because two alkyl groups reduce the electrophilicity of the carbon more efficiently than in the former. Okay, so aldehyde to ketone electronically R group is an electron donating group or electron pumping group. So electron pumping group is electron R group to R group electron pump this carbon becomes more electronegative. Okay, carbon pen electronegative more electronegative, so electronegativity become comparable. So electronegativity pen ke bat sim oxygen dong ke bat sim changina polarity hong polarity hong changina it becomes less reactive. Yeah. Electrophile is not electrophile is not nucleophile attack because of this it becomes less reactive than aldehyde. Aldehyde in the aldehyde in R group R group electronegativity difference between carbon and oxygen is still more and the carbon becomes polarized. Carbon when polarizing nucleophile attack thing. So aldehyde is more aldehyde is more reactive than ketones. Number one, addition of hydrogen cyanide. Both aldehydes and ketones add on hydrogen cyanide to form cyanohydrins. The reaction is carried out by treating carbonyl compound with sodium cyanide and dilute sulfuric acid. So acetaldehyde to acetone. Hydrogen cyanide to reacts in acetaldehyde cyanohydrin. Ketone acetone cyanohydrin. So mechanism the addition of Grignard's reagent. Aldehydes react with alcohol in presence of dry HCl to yield alkoxyalcohol intermediates known as hemiacetal, while ketones react in similar conditions to form ketones. So aldehyde here CHI MGBR and CHI MGX in Grignard's reagent. No, aldehyde to Grignard's reagent forms hemiacetal aldehyde is acetal ketone is ketones. No, so further in presence of further reaction ethanol kinoma aldehydes in ethanol aldehydes akan ethanol kinoma Ketones are the tertiary butyl alcohol. Number 2, reduction to alcohols. Aldehydes and ketones are reduced to primary and secondary alcohols respectively. So aldehyde when it reduces ethyl alcohol, then acetone, ketone when it reduces isopropyl alcohol. Isopropyl here, primary alcohol here. So this one is secondary alcohol. So you take the one in the aldehyde then reduce primary alcohol ketone to reduce secondary alcohol. Number 4, reduction to hydrocarbons. Carbonyl groups of aldehydes and ketones are reduced to CH2 on treatment with zinc amalgam and concentrated HCl. The reaction is Clemmensen reduction of HCl or weight hydrazine followed by heating with sodium or potassium hydroxide in high boiling solvents such as ethylene glycol reaction with Grignard reaction. Number 1 here CO carbonyl group is aldehyde here by the ketone RH is aldehyde or R prime ketone zinc amalgam pen mercury amalgam so reduce you get alkane CO propane CH2 group reduce more. Even though another reaction here hydrazine hydrazine is a with sodium or potassium hydroxide. It gives CH2. So same reaction, different reagents. Number 1 Clemmensen reduction number 2 of Grignard reduction. Number 5 oxidation to acids. Aldehydes are easily oxidized to carboxylic acids on treatment with mild oxidizing agents which oxidizes aldehyde. Aldehyde mild oxidizing agent strong mild oxidation enzymes to react acetic acid. The oxidation of ketones occur under drastic conditions and the resulting carboxylic acids have lesser number of carbon atoms than the parent ketone. Again, the ketone the oxidation reaction a carbon number so example I have in you have 1, 2, 3 carbon atom so oxidation reaction undergoes you get C1 to only 2 carbon atoms. So the product here carbon atom less reducing properties. Aldehyde act as a strong reducing agents. They reduce Tollen's reagent and the metallic silver forms a mirror on the walls of the tube and serves as a test for aldehydes. They also reduce Bunning solution, which is an alkaline solution of copper sulfate containing Russian salt to prevent its precipitation as hydroxide to red Cooper's oxide. Then aldehyde in a Tollen's reagent or Bunning solution in reduce. So Tollen's reagent in a metallic silver test tube metallic silver mirror mirror the only form so certain solution to treat you get red Cooper's oxide. So here aldehyde determining test here. Acidity of alpha hydrogens of aldehydes and ketones. The aldehydes and ketones undergo a number of reactions due to acidic nature of alpha hydrogen. The acidity of alpha hydrogen atoms of carbonyl compound is due to the strong electron withdrawing effect of the carbonyl group and resonance stabilized of the conjugate base. sina alpha hydrogen is ite bangyam is ile C pen functional group no CO pen functional group hai. Next to this, next to CO group is alpha carbon. Okay, alpha carbon. So alpha carbon in a suppose R C double bond O happen CH3 lang talo. Suppose CH3. So CH3, okay. So this with respect to functional group, this is alpha carbon, alpha hydrogen, okay, alpha hydrogen, no. So the alpha hydrogen type is acidic character name. Why acidic? Because CO pen oxygen is highly electronegative. So on the whole, CO pen electronegative danang tamo. Electronegative danang jangina, it pulls electron towards itself. Okay. So electron pen amang pull mo. So in turn, upon pen amang pull mo. So in turn, this carbon pulls electron towards itself. Okay. This one. So this hydrogen are pulled. The electron is going towards carbon. Electron pen carbon bond join mo. So this carbon hydrogen bond pen it becomes polymerized. No, carbon hydrogen bond pen strong nolo. So a strong nolo it becomes easy to break. Okay. So carbon hydrogen pen easily breakable no. Since it's easily breakable, hydrogen pen it can go out as H plus. Okay. So definition of acid is a compound or molecule which can contain hydrogen ion no H plus because of this one hydrogen H plus CH3 hydrogen pen H plus easily break this alpha hydrogens are acidic in nature. Okay. Condensation reactions. Number one, aldol condensation. This involves the combination between two molecules of an aldehyde or ketone in presence of an alkali to form a condensation product known as aldol. So then alpha aldehyde theory is acetaldehyde, two molecules of acetaldehyde can combine form condensation condense form means they form an aldol product. Okay. So formaldehyde, benzaldehyde and benzophenol do not undergo aldol condensation because they will contain alpha hydrogen. So alpha hydrogen formaldehyde, benzaldehyde, benzophenol aldol condensation reaction Number two, Cannizaro reaction. Aldehydes like formaldehyde, benzaldehyde, which do not contain alpha hydrogen atoms, undergo self-oxidation and reduction on treatment with concentrated alkali. So although alpha hydrogen online more. Two, Cannizaro reaction alpha hydrogen name So alpha hydrogen name a product you get alcohol and a sodium formate or an alkali formate. So mechanism OH pen solution NaOH apat NaOH. So OH carbon pen have been positive it's positive. This is slightly positive, this is slightly negative. So minus and plus attracts. Okay. So minus now have attack engine. So electron pen has oxygen gas So OH pen have to form this one. So second molecule, the first molecule first molecule, second molecule. So this molecule na minus oxygen dapat minus electron of na diisocyanate. This one goes here. Then through the carbon electromeric effect it goes to the next molecule, the carbonyl group it join the carbon join time. So you get RCOOH plus RCO minus. Okay. So here ROOH plus RO minus when you conformation, you get an acetic acid, iron and an alcohol. Okay. Benzaldehyde preparation here using chromyl chloride. Chromyl chloride oxidizes methyl group to chromium complex, which on hydrolysis is benzaldehyde. So benzaldehyde when you prepare the inhaler. So chromyl chloride chromyl chloride a methyl group in oxidizing. This oxidizing here you get the product. This is the product. After that hydrolysis. Hydrolysis is something to add more water to add. So water is you get benzaldehyde. Okay. Physical properties of benzaldehyde. It is a colorless liquid with boiling point of 5. So we 4. Number 1, it is a colorless liquid with boiling point of 452 Kelvin and smell of bitter almonds. It is slightly heavy in water, in which it is almost insoluble. Number 3, it is readily soluble in alcohol and ether. Now, benzaldehyde is Romano. No, boiling point is 452 Kelvin here. Again, almond. Then benzaldehyde is water semi so out. Soluble chất lỏng alcohol to ether soluble. Chemical properties of benzaldehyde. The bond oxidation. Benzaldehyde you oxidize benzoic acid. Aldehyde you oxidize acid. The same thing, aldehyde, benzaldehyde on oxidation gives benzoic acid. Number 2, reduction. Benzaldehyde is reduced to benzyl alcohol by sodium borohydride or lithium aluminum hydride in presence of catalytic hydrogenation. So we reduce aldehyde group CHO group in reduced in presence of catalyst or lithium aluminum hydride in dry ether. Dry ether bonded is with water molecule on. So you get alcohol CHO2, CH2OH. On treatment with zinc, amalgam and HCl, reduction reaction or with hydrazine in sodium hydroxide use fractional reaction. Conversion of CHO group to CH3 takes place. So benzaldehyde then aldehyde take reduce bond. Zinc amalgam reduce COH group in CH3. Okay, here more. So benzaldehyde in this work. Number 3, electrophilic substitution. Aldehyde group is deactivating and meta-directing group. Benzaldehyde reacts with chlorine in the presence of a halogen carrier like FeCl3 to give meta-substituted compound. So aldehyde group meta-directing. Meta-directing is electrophilic addition reaction a group any compound electrophilic addition reaction addition in the benzene ring here, no? So any compound will go first to the meta position. Meta position means 1, 2, 3, no? 4, 5. 3 and 5 position. 3 to 5 position ke liye meta position kijiye, no? So Cl2 here first it will go to 3 position. So here metachlorobenzaldehyde ki mo. Suppose excess Cl2 here Cl pen here position tang apai lo din ja. This is another meta position. So it will go. So we have 3, 4, 5. 3, 5 dichlorobenzaldehyde. Carboxylic acid and plan. Carboxylic acid nomenclature. Common name ahile. It is named according to the source from which it is obtained. Muna tak ahile carboxylic de amin kipyam ho. IUPAC name ahile alkan plus OIC acid, alkanoic acid. The structure common name to IUPAC name means something up. Number 1, HCOOH. Carboxylic acid ahile RCOOH. So R pen hydrogen aki substitute jangina you get HCOOH. Kinomo HCOOH pen ahile formic acid akisia. Common name IUPAC name carbon atom ki enzyme. So one carbon atom is jangina meth. So methanoic acid. Anina CH3 CH2OH acetic acid or ethanoic acid. Number 3 propionic acid. Then number 4 butanoic acid. Himani common name butyric acid. It's more. Then propanoic acid. IUPAC name. Common name propionic acid. Different thing. Structure of carboxylic group. In carboxylic acids, the bond to the carbonyl group lie in one plane and are separated by about 120 degrees. The carboxylic carbon is less electrophilic than carbonyl carbon because of the possible resonance structure shown below. So, again here, carboxylic group in a RCOOH group name. So, one oxygen, another oxygen. So, this oxygen electron can come and form double bond resonance. It's in more. Bond can form within here bond in oxygen more. So, this electron comes and form bond. We have single bond on right pen and a double bond on swap more. Oxygen in a electron at the net manina it becomes positive. Okay. So this electron has a double bond on right pen. The electron has a single bond on swap. Because oxygen gains an electron, it becomes negative. So the carboxylic acid though the aldehyde ketone carbonyl group comparative here. Carboxylic acid carbon, this carbon is less electrophilic. It is the carbonyl pena R C O hydrogen. The carbon pen positive oxygen pen negative Then aldehyde carbon in a carbon pen positive charge. Maintain more. Mane here. Carboxylic acid group in a carbon pen positive charge naming more. Resonance structure these electrons are alternating from one oxygen group to another group. Because of this, carboxylic acid is less susceptible to electrophilic addition reactions. Preparation of carboxylic acids. Number 1, From primary alcohols and aldehydes. Primary alcohols are readily oxidized to carboxylic acid with oxidizing agents such as KMNO4 or K2Cr2 or some. So primary alcohol is oxidized carboxylic acid compound. Number 2, by hydrolysis of esters. Hydrolysis of esters with acids or alkalis in acids. The ester to water hydrolysis, it's called as esterification reaction. To water reacts you get acid to alcohol. Number 3, from olefins. Alkenes on heating with carbon monoxide and steam under pressure at 573 Kelvin to 673 Kelvin in presence of phosphoric acid to yield carboxylic acid. So alkene is the olefin, double bond. Unsaturated compound acid to carbon monoxide to twin to 573 to 673 Kelvin heat acid propanolic acid. Physical properties are: number 1, first, 3 aliphatic acids are colorless liquids with pungent smell. The next 6 numbers are oily liquids with an odor of rancid butter. Number 2, the lower numbers are very soluble in water because spot solubility falls with the rising molecular weight. Since solubility is due to intermolecular hydrogen bond interaction, with increase in the size of alkyl group, solubility decreases. Here again, first aliphatic acids are C1, C2, C3. Propionic acid, the colorless liquid, with pungent smell, in the next 6 numbers, 4, 5, 6, 7, 8, 9. C9 kana oily liquid butter give to give answer more. A lower member carboxylic acid C1, C2, C3 water to alchemic stay here higher number carbon chain only increase amount soluble soluble solubility hydrogen intermolecular hydrogen bond interaction alkyl group atom solubility intermolecular hydrogen pen low because of steric interaction. Okay. 3. Some acids boil at higher temperature than alcohols having comparable weight. This is attributed to 2 hydrogen bonds between the pair of carboxylic molecules. Acid carboxylic acid compound at boiling temperature alcohol why? Because carboxylic acid in a dimer form hydrogen molecule. 2 molecules of carboxylic acid can form a dimer. Because of the formation of dimer, the boiling point increases in stable zone. Number 4, melting point of an acid containing an even number of carbon atoms is higher than the previous and next homologue of the series containing an odd number of carbon atoms. So melting point of an acid containing an even number of carbon atoms, melting point pen carbon pen even number higher gig odd numbers chemical properties are there. Number 1, acidic nature. The compounds are ionized in water and give the carboxylic ions and hydronium ions. The carboxylic ion is able to stabilize itself, and that is why carboxylic compounds show acidic properties. Here acid compounds say due to ions to form OH bond pair break or forms minus H form plus. The H plus pair H2O don't form more. So you can see H3CO minus and H3O plus. Okay. The ion form carboxylic acid acidic property. Number 2, reactions involving cleavage of COH bond. Formation of anhydride carboxylic acids on heating with mineral Acids such as H2SO4 or P2O5 give corresponding anhydride. So the ethanoic acid, C1, C2, ethanoic acid, C1, C2. Two molecules of ethanoic acid and in presence of mineral acid heat you get an anhydride. Ethanoic anhydride. Anhydride is removal of water molecule on the water molecule remove. So you get OCO. Esterification reaction. Carboxylic acids are esterified with alcohols or phenols in the presence of mineral acid. Carboxylic acid when in presence of phenol and acid, it gives esters. Reduction number 4. Carboxylic acids are reduced to primary alcohols by lithium hydride, sodium borohydrate, sodium borohydrate, sodium borohydride does not reduce carboxylic group. Lithium aluminum LiAlH4 to NABH4 reducing agent. This one LiAlH4 na carboxylic acid reduced thing no, NABH4 na reduced thing no. So a reduced yang na mga chemicals yan alcohol chemical mo. This part OH gets O part gets reduced to H. Okay. Number 5, decarboxylation. Carboxylic acids lose CO2 to form hydrocarbons when their sodium salts are heated with soda lime. Soda lime is sodium hydroxide to calcium oxide mixed in the ratio of 3:1. So sodium salts of carboxylic acid. Sodium salt. Okay. Sodium, hydrogen tanga sodium hidden metal no. Hydrogen tanga sodium sodium salt of carboxylic acid. No. Sodium salt pen soda lime heat CO2 molecule forms it forms hydrocarbons RH. So R is bone breaks, you get H. Oh. Then the COONA pen na Na2CO3 form. No? So uses of carboxylic acids. Methanoic acid is used in rubber, textile, dyeing, leather and electroplating industries. Methanoic acid rubber, textile, dyeing, leather and electroplating industries. Ethanoic acid is solvent and also ethanoic acid is vinegar. Ini kumo kitchen na ini jadi unlike ethanoic acid vinegar. 3. Hexanoic acid is nylon 6 vomiting acid. Esters of benzoic acid is perfume artificial. So sodium benzoate is food preservative mo. Di take home bang akibolte so pipia kot na sodium benzoate pentesan mo. Higher fatty acids are used in the manufacture of soaps and detergents. Higher fatty acids is carbon chain tampi mo. Asangdog te plant hile detergent consumate and sabon te ho boyan te kesam. Acidity of carboxylic acid. The carboxylic acid carbon is less electrophilic than carbonyl because of the positive resonance shown below. Due to the presence of positive charge on the oxygen atom of the hydroxyl group, this facilitates the release of hydrogen as photon. The carboxylic ion is formed. So formed is a resonance hybrid of two contributing structures. So, carboxylic carbon carboxylic carbon being less electrophilic than carbonyl carbon mo bangja sile resonance mo यहाँ पर the open यहाँ पर down mo. So the final product is this one. So final product when carbonyl carbon or carboxylic carbon is less electrophilic than carbonyl carbon. So is the structures or resonance stabilized? The carboxylic anion is more stable than the carboxylic acid molecule. The acidity of carboxylic acid is thus due to greater stabilization of carboxylic ion. However, in case of alcohols, there is no resonance stabilization and the alkoxide ion is less stable than alcohol due to the presence of negative charge. So, again, carboxylic carbon electrophilic now compared to carbonyl carbon. So carbonyl carbon has CO. So Dana carbonyl carbon pain, the conjugate acid or conjugate base, conjugate acid have an acid here more. Happen acid here conjugate ion pain acid pain hydrogen lab ion here more. So this conjugate ion here is stable more stable so compared to this conjugate ion of carbonyl compound. Also in case of alcohols alcohols na resonance stabilization na ilaw mo. Alkoxide ion is always less stable because there is no resonance in alkoxide. Alkoxide is alcohol. Alcohol pin hydrogen katilag sa alkoxide ion din. So because of no resonance, alkoxide ion is less stable than alcohol due to the presence of negative charge. This carboxylic ion is more stable. This one is more stable than this one. Why? Because this can undergo resonance. Okay. So effect of strength of acids. Electron withdrawing groups increase the acidity of carboxylic acids by stabilizing the conjugate base through delocalization of the negative charge by inductive or resonance effect. Conversely, the electron donating groups decrease the acidity by destabilizing the conjugate base. The effect of the following groups in increasing order of acidity is pH less than iodine, bromine, chlorine, fluorine, cyanide, nitro, and CF3. In aromatic acids, the increase in acidity due to electron withdrawing groups is because of the greater electron negativity of sp2 hybridized carbon to which carbonyl carbon is attached. Carboxylic acid strong acid weak acid no strong and weak acid it depends on the R group no R group electron withdrawing group electron pain the here and electron pain makai group there acidic character of carboxylic acid pain increase no acidic pain on sang but that is the conjugate base pain no destabilizing so conjugate base pain stabilizing through delocalization of negative charge by inductive or resonance effect. So stabilize a negative charge pain stabilize electron withdrawing group of the carboxylic acid pain acidity increase more. However, electron donating group of the conjugate base pain destabilize more. So the conjugate acid pain destabilize more a carboxylic acid acidity pain on young more. Benzoic acid is something more. Benzoic acid structure in the C6H5 this part. Benzene ring. Okay. C6H5 COOH. Benzoic acid hele carboxylic acid ada member important kata hina. Benzoic acid hele free state ina gum benzoin ini semua resin ya natural resin ma. Resin kung nakakin pangkate akila kete hina. It is obtained from trees in combined state as benzyl ester or as benzoyl glycine, hippuric acid in the urine of horses and oxygen. Preparation of benzoic acid. Benzoic acid ahile bangsi boarding ya masile benzyl chloride in presence of alkaline KMnO4. So benzoic acid here sodium benzyl alcohol. Or benzaldehyde being potassium hydroxide topirate sodium benzoate kimua sodium benzoate being acid to react again benzoic acid. Physical properties of benzoic acid. It is a white crystalline solid with melting point of 3.5 Kelvin. It sublimes when quickly heated and steamed for the time. It is sparingly soluble in cold water but soluble in hot water, ether, benzene, and alcohol. Its vapor has pungent odor. Benzoic acid hele white crystalline solid it's not see to kibang no. Melting point hele 395 Kelvin here. Heat na supply tanga vapor makazil mo. When quickly heated and steamed for the time. Benzoic acid hele hot water soluble kiya bangge hot water heater benzene alcohol soluble no dissolved hai vapor hele pungent odor pungent is similar gimha hat similar. Chemical properties of benzoic acid. Salt formation with alkalis, carbonates and bicarbonates. The benzoic acid here sodium hydroxide topirate you get sodium salt of benzoic acid plus water. Number 2 reacts with phosphorus pentachloride to form benzoyl chloride. Benzoic acid PCl5 topirate you get benzoyl chloride C6H5COCl plus POCl3 plus NCl. Number 3 when reduced to lithium aluminum hydride it gives benzyl alcohol. Benzoic acid pen reduce benzyl alcohol. Uses of benzoic acid. Benzoic acid here sodium salt of benzoate preservative of the Number 2 benzoic acid here urinary infection Number 3 a vapor form when it is infectant bronchial tubes Number 4 it is used in the manufacture of dyes dicarboxylic acid or oxalic acid. Structure here COOH oxalic acid here plant plant kingdom ama here potassium hydrogen oxalate in wood soil to tobacco ammonium oxalate here urine swang ammonium oxalate Preparation of oxalic acid. Number 1 oxidation of glycol. Glycol here oxidized oxalic acid OH group then oxidation reaction acid oxalic acid. Number 2 it is prepared in the laboratory by the oxidation of sugarcane by nitric acid, the group CHOH is oxidized. Here, fluorine to nitric acid at ibang pagtangina, oxalic acid mo. Physical properties of oxalic acid. Oxalic acid ay a crystal structure with 2 molecules of water of crystallization. The melting point of hydrated acid is 374.5 Kelvin, and anhydrous acid melts at 462.5 Kelvin. Oxalic acid hydrated is water molecule water molecule for oxalic acid 374.5 Kelvin melt in anhydrous is water molecule dry. Only oxalic acid 462.5 Kelvin melt. Number 3, oxalic acid dissolve dissolve oxalic acid dissolve alcohol also dissolve but insoluble in ether. Ether dissolve. Chemical properties of oxalic acid. Number 1, formation of salts. It reacts with alkalis and carbonates to form salts, just as observed for monocarboxylic acid. Oxalic acid alkali we get alkali salt of carboxylic acid. Number 2, action of glycerol. Oxalic acid PCl5 PCl5 and phosphorus tetrachloride CO carbon monoxide to COCl2 produce COCl2 phosgene gas phosgene gas danger poisonous gas cut. Number 3, when heated with H2SO4 it yields CO and CO2. Oxalic acid concentrated sulfuric acid CO2 plus CO Number 4, oxalic acid formic acid plus CO2 Uses of oxalic acid, it is used for removing ink stains from cloths. Oxalic acid ink stain pen stain Number 2, volumetric analysis standard reference Number 3, ferrous oxalate photographic photo development Number 4, metal polisher oxalic Number 5, formic acid pen prepare oxalic acid aldehyde, ketones and carboxylic acids emit is in